We'll go ahead and start up in just a second. All right, hopefully people are joining and will be able to hear me. Let me go ahead and get everything set up and ready to go here. All right, looks like we have people joining. Fantastic. So let me go ahead and get started. So welcome to the 6th virtual office hour and live lecture for the POSA Communications MOOC. We have about 4 things we're going to do today. The first thing we're going to do is we're going to go through another set of slides that finish off the bound services with AIDL discussions. And I added these slides because I realized that we hadn't gone into enough detail about some of the important topics you'll need to know when you do the programming assignment, the 3rd programming assignment. So that's one thing that we'll do. Another thing that we're going to do is we're going to walk through a new version of the Acronym application, which will illustrate some of the cool concepts that you'll need to do in the 3rd programming assignment. And then we're going to go over the 3rd programming assignment. And then the last thing we'll do, or maybe we'll do this thing earlier, we're going to go through my solution to programming assignment 1 so that everybody will be ready to help out with peer assessment. Okay, so the first thing let's do, let us go ahead and talk about some more about bound services and AIDL. All right, hopefully everybody can see my screen. Let's put this over in the right place. Okay. What we're going to do now is we're going to talk about more information regarding the Android interface definition language and the binder framework. And we're going to talk about some of the key capabilities provided by these frameworks using the bound download application as a running example. And we're going to show some more details about how you could interact with bound services both synchronously and asynchronously. And as you hopefully know by now, AIDL and Binder support statically typed object-oriented inter-process communication via the proxy and broker patterns. We'll talk about those patterns probably starting next week. So what is the reason for having AIDL? What problem is it solving? And it's basically solving the problem of simplifying inter-process communication between activity and service components, especially when they run in separate processes. That's the main motivation. Rather than having to encapsulate marshalling and demarshalling mechanisms, or rather than having to write marshalling and demarshalling by hand, the AIDL and Binder encapsulates the tedious and error-prone aspects of having to write these things manually. Another benefit it provides is it provides thread pools to concurrently process remote method calls. Remote here meaning running in a separate address space, not running on another computer. It's running in a separate address space on the phone or on the tablet. There's an AIDL compiler. It generates proxies and stubs that are used at several points in the path from the caller to the callee. Here's a simple example of an interface, not unlike the one that you guys are using for various things. So this is a download image method defined in the download interface. And the AIDL compiler generates code that will convert the caller's data into so-called parcels. That's done by the proxy. And you can read more about parcels here. There's actually some useful things about parcels that are really important to know for the next assignment. These parcels are then copied from the caller's address space, the process, to the callee's address space in its own process. And then the stub demarshals the parcels into the format expected by the callee, which is, in this case, would be Java, but could be C or C++ for that matter. And then that's basically all that there is as far as the code that's generated by the AIDL compiler. Now, there's a couple of different ways you can invoke methods. And this is really what I wanted to cover in more detail because we didn't go into it enough last time. And people have been asking questions on the discussion forum that make it clear that additional coverage would be helpful. So the most straightforward way of doing things are to make two-way method calls, which are synchronous. That means they block the caller. This is the most straightforward model because it looks pretty much like programming a normal method call in Java. But of course, there's actually some magic going on under the hood with the proxies and stubs and the binder and so on to do all the communication between address spaces using the broker and proxy pattern. So here's an interesting twist on this. If you don't have the service, you don't have the receiver of the AIDL running in a different process, if it's running in the same process, then these calls the two-way calls will execute in the same thread that made the call. This is a little bit confusing at first, and it's documented in the Android documentation. If you take a look at the link down here, you'll see that it says this, but it's a little bit confusing at first. So when you co-locate the caller and the callee, when they're in the same address space, then the thread of the caller is used to do to run the two-way call. Now, this is going to, of course, be very problematic if you're doing networking calls in the callee's function, because you'll end up, and if you're running on the main thread of control, the UI thread, because you're going to end up trying to do networking operations in the main thread of control. So we'll talk more about that later. That's a big no-no. So you have to be careful with that. The more interesting case, which is what we're going to cover here, is where you're doing the calls to a remote process. And so in that particular case, if you're calling from one process to another, then the processing takes place in a pool of threads, in one thread in a pool of threads. And the binder framework maintains this pool of threads inside of the process. So what'll happen here is the caller thread will block waiting for the results from the service. The computation in the service will run concurrently in one of the threads in the pool of threads. And then once the result comes back, the caller will unblock and will continue doing its processing. And of course, the implementation is run in the thread. Now, one of the consequences of this is that two-way methods, even if you have something running in a separate process on the receiver side, could still conceivably block the main thread of control for an extended period of time. If you end up doing a very long-running computation in the background server process, then you'll end up blocking the client caller for an extended period of time, which is not a good thing. So for that reason, you should generally invoke two-way method calls off the user interface thread. In other words, by using an async task or spawning a thread or whatnot. I like to use async task because that's pretty clean. But one of the consequences of this is that even for two-way calls that are going to be running in a separate thread, you still need to make the invocation of the method call from the activity or the client's perspective running in a separate thread. And that's a little bit unclear at first why you have to do that, but that's basically the way it should work and what you have to be ready to do. And if you take a look at the examples we're about to show, we do that. Now, one-way method calls behave somewhat different than two-way method calls. So if you have a one-way method call, then the caller, the one that's doing the call, doesn't block waiting for the results. It starts the call and then goes on doing whatever it wants to do. The callee method will execute asynchronously from the caller in whatever means has been defined, keeping in mind we're focusing on the remote case here. But if you're doing a local call, if you have a co-located call, then the one-way call still executes synchronously because it's just invoking a method in the same thread of control as the caller, and that's a little bit weird. So you have to be prepared to understand these subtle differences between the semantics of two-way and one-way calls and how they relate to things that either run in a separate address space or not. So be prepared for that. You have to to know that there are differences. This is described in the AIDL documentation, but they don't really explain in the documentation how to do it properly. And so that's kind of what we're talking about here, and we'll show some examples to make it more clear. Now, given the fact that you can make one-way calls, then you can have two-way asynchronous calls between processes by using a very simple pattern. And this basically avoids the problems that we saw before, where you have a client thread blocking during a two-way synchronous call. Of course, you can solve that problem by spawning an async task to do the client-side operations, but that might be extra tedious, and you might not want to do that, and you have to be a little careful when you do that. So what we're about to do is show more of an event-driven way of doing processing with AIDL that uses two-way asynchronous calls. And the way you do this is you implement two AIDL interfaces, each of which has one-way methods. So as you can see here, we have download results and download request. So download request, of course, is implemented by the server, by the service, and download results will be implemented by the client, by the activity. Download request will take the download image request and go ahead and run that in a separate background thread. And in addition to the URL that's passed in, it also takes a download results object, which is a reference to an implementation that lives over here on the activity side. Notice that everything that we're passing with one-way calls are all in parameters. That means that they're copied from the caller to the callee. There's no way with in parameters to be able to pass back an out parameter or a return value. So they're always void, and they always only take in parameters. After the download request operation is finished, then basically it turns around and does a download results, which calls back to the send path, and that will then give the path back to the activity, which can then display it or do whatever it wants to do with that. Notice in this case that the client side also has a pool of threads, and send path is actually executed in a background thread in that pool of threads, which causes a little bit of extra work on your behalf, because you have to turn around if you want to display the results and do a basically run on UI thread method to get it back in the UI thread. These are all one-way calls, so they don't block, and we're assuming here that things are running in separate address spaces. So keep in mind that a one-way method can only pass parameters from the clients to the server. It doesn't have any out or in-out parameters, and it has no return value as well. So now that we understand that, we can kind of show the way this works. The caller will create a results object reference, and it'll pass the object reference via the one-way call along with any other parameters. That does not block the client. The callee method then executes asynchronously in a thread, and when it's done, it sends the result back, and that comes back in a separate thread. So by the way, that the callback does not block either, and then a thread will be selected to run the results back in the client activity. I actually prefer this model of AIDL. This is the one that I've come to know and love over time. Even though it's a little bit more complicated and transmits more data, it's also more flexible, and it's less error prone in a lot of ways, because you don't have to worry about things blocking for too long. And another thing that you can do with this, and we'll see this when we talk about the Acronym application in a second, you can also pass back much more useful error information, because you can provide different kinds of error methods that you might have on the download results interface. And so if something goes wrong on the server side, you can call some kind of error handler. One of the other things that does not occur with AIDL is there's no way of passing exceptions back from sender to receiver. So this is probably the cleanest way of passing an exception back, is to define an error method that gets called back if something goes wrong. The invocations that span process boundaries run in the thread pool, and that means that any of the shared state, any state that's shared by the stub implementations, must be synchronized to avoid race conditions. So if you end up having variables that are part of your activity or your service, and they're accessed in multiple places, including threads that are running in the pool of threads, you need to make sure that they're properly synchronized, or you'll end up with race conditions, and your code will have subtle problems in terms of being inconsistent and corrupted. Okay, so to summarize this, Binder and AIDL provide a number of capabilities that allow objects to communicate in separate processes. They provide an object-oriented inter-process communication mechanism, which is pretty straightforward to use and works quite nicely, especially if you have complex data types. You can basically mimic typed method calls between Java objects, except you can do them between objects that reside in different address spaces. Explicitly typed interfaces are less tedious and error-prone than the messages sent via the generic messenger mechanism that we looked at earlier, where you have to keep track of all the different extras and keys and all the other things, and it's very hard to tell at a glance what the interfaces are and what the message sets are. It gets very complicated very quickly. Another thing that you get with AIDL and Binder are the ability to have thread pools provided automatically to run things concurrently. These threads are managed by the Binder framework, and I think there's typically, I want to say, 16 of these threads. So as long as you have less than 16 concurrent invocations, you're fine. It shouldn't block. Another nice thing about having all this stuff done by the Binder framework is you don't have to worry about threads, messengers, handlers, runnables, messages. All that stuff is shielded from you in most of the cases. However, in some ways, messengers provide more flexibility because they don't constrain or limit the concurrency model. You can either have things be concurrent or not, and you can decide. Whereas with the AIDL, if you start talking between remote processes, you're going to be having a pool of threads, and you're stuck with that. Messengers, in contrast, don't mandate any particular concurrency model. So you can have them be single-threaded, you can have them be multi-threaded, you can use your own thread pool, you can do a thread per request, you can do whatever you want to do, and it's a little bit more open-ended, although you have to be the one to do it. Activities and services can communicate via two-way synchronous and asynchronous interactions. If you understand the patterns of asynchronous programming, things like the proactor pattern or active object pattern, then the asynchronous model is very clean. I really like those approaches quite a bit, and understanding active object and proactor can help you understand the way in which the various pieces are broken up. We'll talk more about those patterns later. You can also use these mechanisms to interact between different languages, Java, C, C++, and so on. Writing bound services in C and C++ is not well documented, although there is an example here of how to do it, written in, I believe, in C++, that you might take a look at, although it's entirely not well documented. There's also a whole pile of Android system services that are written in C++, although these services are not services in the sense of the started and bound services we've been talking about here. They don't extend the service class, for example. They work with something called the service manager, which ironically enough does not use the Android service framework. So even though these are services, they are slightly different than the services we've been talking about. Okay, so that's basically a quick overview of more information about services. We have a number of questions that have come in, so I will take the questions, and then we will go ahead and move on to the next discussion. So where is the data structure defined with AIDL? How does the other side know about what structure the data is in? So there's a number of sort of built-in types that are understood by AIDL out of the box. So you get things like all the primitive types, int, short, double, all that kind of good stuff. And then you can also have lists of those. String, of course, is supported. So all the kind of the basic types and arrays and so on, lists of basic types are all supported. So it just knows about those by its very nature. If you have classes that are your classes that you want to be able to pass back and forth via AIDL, then you have to use a mechanism we'll talk about here shortly that involve parcelables. And you can define these things as parcelable, and then you have to define some code that implements the parsable mechanisms, and then the AIDL compiler and so on will know how to send those back and forth as well. And we'll take a look at that in the context of the Acronym application. So the answer to your question is it either knows it because they're kind of built into the type system of AIDL, or because you have extended the type system of AIDL using parsalables, and you've told the runtime system in the compiler and so on how to grab the various mechanisms to make all that work. And we'll take a look and see how that works. Can we use the acronym project as a skeleton and rip out what we need and then add what we don't need and add what we do need to support the functionality? Sure, you're welcome to do that if you want to. If you don't want to do that, that's fine too. You're welcome to either use acronym as a starting point or not. You'll see when you start to use it, there's a bunch of things you'll have to do because there's a lot of things that are different. For example, the JSON schema for weather data is very different from the JSON schema for acronym data. So you'll have to figure out how to write a different parser to handle that. And you'll also have to do things like add in the cache and so on and so forth. And then the interface is different and so on. But yeah, you're welcome to start with that if you want. Do we have timers that bound the callback to catch the service crashing? Does the AIDL framework detect a remote failure? Not very conveniently. AIDL out of the box has some limitations that make it problematic to use. And one of them is that there's no real good support for exception handling. That is yet another good reason for being able to use the two-way asynchronous pattern I talked about, because you would have greater control over not blocking yourself indefinitely if the receiver, if the callee were to hang for an extended period of time. Let's see, how many threads are there per thread pool? I believe it's 16 threads per process. Someone needs to probably double check that, but back a number of years ago when I looked into this in more detail, it was 16 threads in the thread pool per process. And you may be able to tune that. I'm not sure. That's a good thing to look into. AIDL is more powerful than bound service, which is more powerful than started service. Well, you're kind of comparing apples and oranges here, okay? So bound services and started services are a framework for being able to run things in the background. AIDL and messengers, and there's some other examples too, but let's focus on AIDL and messengers, are inter-process communication mechanisms that can be used to communicate between components, where sometimes the components are activities and services, sometimes the components are services, and so on. So the way to look at it is you can use messengers as an inter-process communication mechanism to communicate between an activity, or rather a started service and an activity. You can use a messenger to communicate that way. You can also use messengers to communicate between clients and services, or activities and services, using bound services. So basically the way to think of it is that a started service can be used to communicate via messengers. Started services can be used for messengers, and bound services can also use messengers. So the messengers are more generalized. AIDL is really only intended to be used with bound services. You could probably do crazy things to make them work with started services, although I've never seen anybody do that. It's possible, I suppose, in order to do that, but the most common thing to do is to use it with bound services. And I guess it really couldn't be used with started services, because you have to do the whole protocol for starting things up, and that really requires a bound service to kick the protocol off, and so on and so forth. So AIDL is a communication mechanism that does a lot more of the work for you in terms of encoding and decoding, or marshaling and demarshaling the data that's passed between method calls. So AIDL is a method-oriented communication mechanism, whereas messengers, as the name implies, is a message-oriented communication mechanism. And each has their pros and cons. AIDL takes a little bit more to kind of set up, although it's quite easy to use once it's set up. Messengers are a little bit easier to use at first glance, although they don't scale up quite as well, because you quickly get lost in all the implicit nature of messages, which makes them more tedious and error-prone to use. So they have pros and cons, and you could also use AIDL with hybrid started and bound services as well, and that's something that the music player service on Android does. Okay, so two-way calls are blocking calls. Yes, two-way calls are always blocking calls. And one-way calls are non-blocking and always run using a pool of threads. No, this is very confusing. The way it works is if you co-locate the caller and callee in the same process, all calls are blocking calls, whether they be one-way calls or two-way calls. If you distribute, using the word loosely, if you remote the caller and callee in separate processes, then two-way calls are blocking calls and one-way calls are non-blocking calls. And in either case, whether it be one-way or two-way calls, they run in a pool of threads in the callee. So the callee side always runs in a pool of threads if you're running in a remote process. But when things are co-located, everything turns into a blocking call. So that's a little bit confusing, I know, and I know why they did that. It's just a heck of a lot easier to do it that way in the implementation, but it does lead to semantics that are a little bit confusing to people. But that's just the way it works, and if you don't like that, you'll have to find some other mechanism to use, because that's the way it's built out of the box in Android. In some sense, they're kind of mixing policy and mechanism a little bit too obtrusively. Okay, so that looks like those questions are done. Those are good questions. Let us now go and take a look at some code. So what I'm going to do next is I'm going to bring up, darn it, my solution for, or actually I'm going to show you an example now. Let's go ahead and share the screen. All right, so hopefully you can see the screen, and hopefully I can find my example. Okay, so this is a new example. This is the so-called acronym example that's in the POSA 15 directory. Make sure that you look in the POSA 15 directory for this example. Don't look in the POSA 14 directory. There is an acronym example in POSA 14, but it's not this example. It's an earlier example that uses deprecated Android HTTP client mechanisms, which I actually happen to like quite a bit, but they've been deprecated, so can't use them anymore. Here's the manifest file for this example. It's got a main activity, and it's got two services, the acronym service async and the acronym service sync. Now, the acronym service async needs to run in a separate process, otherwise it won't work. The acronym service sync could actually run in the same process as the client activity, and you'll see as we talk about it why that's the case. I ran them in two separate processes just for the heck of it, but it doesn't have to do that. Take a look at the source code. This implementation follows the pattern that I've been applying for most of the other examples recently, where we basically split things up into separate packages based on their common behavior. So we have activities, we have operations, we have services, we have utils. That's pretty common. We almost always have that in the examples. We have a couple of other packages here that we have AIDL, which is where the AIDL types reside. And we have this thing called JSON acronym, which is what's actually going to be parsing the data that we download from the Acronym web service. So there's a web service that you can use to expand acronyms. It's somewhat of a limited service. It seems to be heavily slanted towards medical acronyms, lots of stuff for medical stuff, not so much stuff for computer science. For example, OOP is not defined here. If anybody can find a better publicly available acronym web service, let me know. It would be fun to improve the service that's used here. Let's go ahead and take a look at the activities part first. As usual, we have a lifecycle logging activity that is used to log things. We have the main activity. The main activity works the same way that almost all of them have worked so far. Very little is going on in the main activity other than basically handling screen rotation and handling certain lifecycle operations that are important. The only piece of state that's in the activity at all is called acronym ops. And we do this particular pattern, or I guess it's really an Android idiom, to make it easy to handle state updates when we change the orientation of the screen. If you don't do something like this, you have a lot more state to have to manage explicitly, and it becomes diffuse and hard to reason about. So we have a retain fragment manager that's going to handle rotations. We have an acronym ops. And then down here, we have the onCreate method, which sets up the main activity display and then handles any configuration change that may have occurred. The onStart method simply turns around and calls bind service, and the onStop method calls unbind service. These are just calls that are defined on the acronym ops object, and of course, they're going to end up doing some other stuff that will actually do the real binding and unbinding, but we just trigger them from the onStart and onStop because that's where they're supposed to happen with respect to Android's activity lifecycle operations. Here's handle reconfigurations. The first time in, we create a new acronym ops impl, and we stick that into the fragment manager. And then any second or subsequent times, we go ahead and look up the acronym ops state. And if for some very, very odd reason it's null, we go ahead and create a new one. That should not happen under normal circumstances, but as the comments say here, it's better to do it this way than to crash. Otherwise, if we've got the state, we tell the ops object that a configuration changes has occurred, and it updates itself with respect to its internal state that relies on activity-centric data like views and other kinds of things. Okay, here's the key methods that are defined in the user interface: expand acronym sync and expand acronym async. Those are the two methods, and all they do is they simply forward through to the acronym ops to the corresponding method that does the acronym sync processing or the acronym async processing. I've really come to like this particular way of arranging things because it keeps the activities really simple and clean, and everything goes in a very stylized way. And then all the hard stuff goes in other classes, but they're carefully diffused, so it's easier to reason about. Here are the operations methods, or classes and interfaces. We have acronym ops, which is an interface, and it simply defines the public signature of the methods that are needed to implement this service. And I do this just so it's easy to tell at a glance what we're dealing with here. So we've got bind service and unbind service. We've got expand acronym sync, expand acronym async, and we've got on configuration change. That's just a simple interface that we define what an acronym ops is all about. Here's the implementation of this thing. It implements the acronym ops impl, implements the acronym ops interface, and it goes ahead and defines some information that'll be needed, like the activity that we're associated with, a bunch of views, the list view, the edit text view, and so on. Notice these are all weak references, so we can avoid strong references and the garbage collection headaches that causes. We have something called an acronym data adapter, a data array adapter that's used to display the acronym output in a clean way. We have some really super cool stuff here. I did this in a MOOC from a year or so ago. This is called a generic service connection. And basically what this does is it hides all the details of the protocol handshaking operations that have to be performed on the client side. And I'll show you this implementation in a second, but it really cleans up the code for bound services. So as you can see, a generic service connection is parameterized by the type of AIDL interface we want it to work on. So we have the synchronous version, the acronym call version, and the asynchronous version, the acronym request version. And then if we go over here, the utils directory, and we look at generic service connection, here's what this thing actually looks like. So the generic service connection is basically a generic class whose parameter extends Android OS I interface, which is the base class of AIDL interfaces, and it implements service connection. We have some cool things that are used with a Java reflection, which we're going to see here. And so you can see we have this thing called stub as interface, and we also have a class that we're going to use to load the appropriate things. We'll see how that gets used in a second. Here's the AIDL interface. We have an instance of AIDL interface. AIDL interface, of course, is the parameter that's passed into this thing. We're going to have a stub class that is used to implement this interface. Here's the method we're going to use to get it as an interface. Here's the method that returns the interface that we're going to have. You'll see how that gets used later. Here is the constructor. The constructor is going to take a class that implements the AIDL interface. So in this case, that would be either the acronym request or acronym call class. And so it's going to take a class that implements that. And then basically what it does is it goes ahead and it uses Java reflection in order to find the stub that is associated with this class. So we go ahead and we say, go look up in this class and find all the declared classes. Find one that has the name stub. And when you find the stub, go ahead and grab its asInterface method from the stub. And once we get that, we go ahead and stash away the stub and we stash away the method. And then we define the on-service connected and on-service disconnected methods. And check out what they do when they're called. When on-service connected is called, which is a callback method from the point of view of Android, it goes ahead and it uses the asInterface object that we got, as it uses the method asInterface, and it goes ahead and invokes that method on the stub, passing in the iBinder service that's passed as a parameter. And what that'll do is that will go ahead and basically return the it'll return the interface that goes along with this thing, and it gets stashed away in minterface. And so therefore, when someone calls minterface later, it'll get back the right interface. So what we're basically doing here is we're defining a little helper class that shields all the details of dealing with the three-way or the two-way protocol handshake that bound services do. So go back over here. So generic service connection basically will do all this stuff for us under the hood. We'll see how that gets used in a minute. Here's the constructor for acronym ops impl. It creates a weak reference to the activity as always. It initializes the view fields and it initializes the non-view fields. I guess if I was really being good, I would move this stuff down. Let's do that, since otherwise it's cumbersome. All right, so here's what initialize view fields does. It uses the mActivity weak reference to get various weak references to edit text and list view, and also set the layout of the main activity. And then here's what initialize non-view fields does. That goes ahead and makes a new generic service connection parameterized for the appropriate type of AIDL interface using the appropriate class that implements that interface. And so you can see how much cleaner and shorter this code is than having to write that service connection logic all over the place in your client. And this is especially true in this example because we've got multiple instances of service connection, one for the synchronous, one for the asynchronous version. So this is much cleaner and shorter. Here's what bind service does. Bind service, remember, bind service gets called here. So in the main activity, when onStart is called, we call bind service. And we need to have this designed because onStart and onStop are the lifecycle hook methods that activities use to say do stuff when we're starting to become visible. And that's where bind service and unbind service need to be called. Of course, we don't want to have the details of that exposed at this point, so we simply do forwarding calls to the acronym ops class, and then that ends up here. So bind service gets called, and then we turn around and we say mService connection sync get interface, which at this point should have been set up. And if this is not null, in other words, it's been initialized with the handshake, then we go ahead and we say call bind service on the activity, and then we go ahead and grab the intent that'll be used to start the sync service and the intent that'll be used to start the async service. And we go ahead and call bind service, passing in those intents and then passing in the service connection object, the sync version or the async version. So again, this is heavily abstracted, but really cool, really canonical. I pretty much would always write my bound service code this way because it's just so easy to work with, and it's very consistent and uniform. You can tell at a glance exactly what it's doing. It's very clean. And so that's kind of how that process works. Here's unbind service. You can see unbind service. If the interface is not null, it just calls unbind service, passing in the service connection async and service connection sync, and then using the activity as the context to call unbind service for both those services. All right, so that's unbind service and bind service. Here's on configuration change. When on configuration change gets called, we're basically going to reset the M activity, and then we go ahead and reinitialize the view and non-view fields. Okay. Here's the expand acronym async method. This is the one that gets called back when we're doing asynchronous calls. We go ahead and grab the interface, if it exists, from the service connection async object. And if it's not null, we get the acronym that was entered by the user. We hide the keyboard. And then we go ahead and we make a one-way call to the expand acronym method, passing in the acronym that we want and the acronym results. Acronym results, as we'll see in a second, is basically the object that is used to call back when things are done. Here is the expand acronym sync method. Once again, we get the acronym AIDL interface. We get the acronym call version of this thing. We get the string, hide the keyboard. And now we have to do something a little different because this is going to be a two-way call. So this call would otherwise block the UI threads, and we don't want that to happen. So what we're going to do is we're going to make an anonymous async task, and it's going to take a string as the parameter, which is the acronym to look up, and it's going to return a list of acronym data if all goes well. And then we do the do in background call here. And do in background, of course, runs in the background. That goes ahead, stores the acronym we're looking up in a local variable, calls the expand acronym call. This is a two-way call now. I guess I should really do this as an acronym. It does the two-way call through the reference to the AIDL interface. And then when that thing is done, we go ahead and we have on post execute called. And in this particular case, if you look at the service, if you get back an acronym data list that's greater than 0, it means you actually got useful results, in which case we display them. If you get back something that is 0, that means that there were no expansions found for this acronym. So we print a toast out in that case. And the anonymous async task that we're creating here, this anonymous async task, this goes ahead and is executed, passing in the acronym that we're looking up. So that'll go ahead and run in the background. Here's one of the last pieces of the puzzle here. This is acronym results. This is how we get callbacks from the service to the application, to the client activity. This will run in a separate thread of control because that runs in a background thread. One-way calls are dispatched like that when they come from a separate process. And in this case, when send results is called back, it'll take the acronym list and it goes ahead and displays the results. But it does the results display by making a new runnable that is run in the UI thread. So it calls run on UI thread. So it'll take the results that came back and run them in a command that executes back on the UI thread. Now, the other thing we can do with an async approach, which is kind of cool, is we can have a separate way of handling errors. So send results, send path will get us back send results will get us back the results. But if something goes wrong, we can have a separate method called send error, and we can give the reason for the error. So it might be because there were no acronyms were expanded. You gave it an acronym it didn't understand. The service didn't understand. So in this particular case, this is the send error method, and that's a little bit more open-ended and cleaner than the two-way synchronous call that we looked at before. Here's a display results method. It's very simple. All it does is it takes the results and it puts them into this acronym data array adapter, and then it goes ahead and sets the adapter, and that will then go ahead and display the output. And if you look at the output, it basically tells you the I think it tells you something like the frequency with which these acronyms have appeared, the acronym itself, when it was defined, that kind of stuff. So that's the information that you get. Okay. So that's basically the operations data. Let's go ahead and take a look at services now. And you'll see that we have a couple of things here. We have lifecycle logging service, which is the base class that we use, so we get logging information. And then we have the sync and async service implementation. Let's look at sync service first. So sync service inherits from lifecycle logging service. Its onBind method returns acronym call impl. Let's see where I define that. Oh, it's probably down here. Yeah, acronym. Here's acronym call impl. Here's the static method. So move this up. I like to put the static methods first because they're the first thing that we're going to call. So this is the make intent method that just makes an intent for starting this. Here's the onBind method, which is going to return the acronym call impl as an iBinder. Here's the acronym call impl implementation, which inherits from the acronym call stub. Acronym call stub defines the expand acronym method, which takes a string. And then that goes ahead and calls into the utils class and calls the get results method, passing in the acronym. We'll take a look at this later. That will return a list of acronym data called acronym results. If that list is not null, that means we actually found acronyms that matched and we return them. Otherwise, if it was null, it means that there were no acronyms that matched. So we just create this basically zero-sized, create a zero-sized acronym results object to indicate to the caller that the acronym had no expansions. So you couldn't expand it. That's just a way to signal back that information. There are other ways to do this, of course. This is just a simple way to do it. So that's basically all there is. As you can see, the actual service implementation itself is very small. All the hard stuff actually goes into this get results method, which we'll look at in a second. Let's now take a look at acronym service async. Acronym service async extends lifecycle logging service. Once more, let me put the make intent method up here first. I guess we don't really need the tag anymore either, because I think there's a tag that's defined there. Let me fix that over here too. All right. So here's the async version. It's got a factory method to make the intent. It has an onBind method that returns the acronym request impl. Here's the acronym request impl, which is an acronym request stub. It overrides the expand acronym method. The only main difference between this and the two-way version is that this takes a callback object that comes in as the first parameter. And just like before, it goes ahead and uses the get results method in utils to get the list of acronyms. And depending on what we get back as a result, we either call send results or we call send error. So if we don't find an acronym expansion, we send an error back. If we do find acronym expansions, we call send results. So that's basically acronym service async. Once again, you can see very straightforward, very clean. Let's now go take a look over here at utils. So we've already looked at generic service connection. We've looked at retain fragment manager before. Those things are the same as always. Acronym data array adapter is basically just something that can be used to convert the results into something that can be displayed as an array of data. And I won't go through that in detail, but this is basically just using some stuff that's defined in the resources layout directory to lay out the results in a nice, clean way. And it's commented to explain how it all works. Take a look at utils. This is where some things actually get done that are interesting from the point of view of the details of all this stuff. So here we've got the URL of the acronym web service, which, as you can see, is a static variable that goes to this location in the UK. Here's the get results method. This takes an acronym. We create ourselves a new array list of acronym data. I'll show you what acronym data is in a second. We then go ahead and create a list of JSON acronyms, which we'll look at in a second as well. We then go ahead and create a URL, which is the web service URL for the acronym service, plus the acronym we're looking up. We open up an HTTP URL connection. And then we go ahead and we create a new buffered input stream. And we create a new thing called an acronym JSON parser, which we'll look at shortly as well. And then we go ahead and we parse the stream of data using the acronym JSON parser, and we get back a JSON acronyms list. That's what we do if all goes well. Let's see, let me reformat this. For some reason, Emacs doesn't seem to understand try with resources, which is annoying. All right. Now, if we get back a JSON's acronym list that has something in it, then we're going to do this code. If we get back nothing in it, it means that something went wrong. Either the stream was malformed, or there was more likely there were no acronyms that were found, no acronym expansions that were found. So we return a null, indicating that we didn't get anything. This is the more interesting part. If we get back a list of JSON acronyms, we iterate through the list of JSON acronyms, and we create a new acronym data object. And I'll show you what acronym data is in a second. Acronym data is a parcelable that can be passed between address spaces in Android. And we create the acronym data by passing in the appropriate fields that we care about from the JSON acronym object. So the long form, the frequency, and when the acronym was first defined, at least according to this web service. So we're creating this thing called an acronym data as a result of this stuff. And there are a few other methods here that aren't worth talking about. So we're making good progress here, but there's still a couple of things that need to be understood. And this is very important for your next assignment as well. And those things we're about to talk about are, how do we parse the JSON data, and what's the format for the AIDL that we're going to be passing around. So let's go ahead and talk about the AIDL stuff first. So what we have here is we have an acronym call method, or acronym call interface, that has a method called expand acronym that takes an in parameter as a string and returns a list of acronym data, where acronym data is something we define, which we'll show you how to do that in a second. Here's acronym request. This is a one-way call, which will take in the string for the acronym and the reference to the callback for passing the results back. It's a one-way call, so it can't return any result, and it can't have any out parameters or in-out parameters. And here's acronym results. Acronym results. Oops. Acronym results basically defines a one-way call called send results, which passes back a list of acronym data, and then send error just passes back a string if something failed. All right, so far that's pretty straightforward. Now let's take a look at the stuff that's more interesting. We also have something called acronym data AIDL. And acronym data AIDL defines acronym data to be a so-called parcelable class. And what you have to do this so that the AIDL compiler knows that it has to figure out how to find the implementation of acronym data to learn how to encode it and decode it so it can be passed back and forth using the mechanisms that are provided in Android for passing around Java objects through the AIDL framework. So we define acronym data, which is a class we define as being parcelable. Now, let's go take a look at acronym data.java. So this is where all the logic goes for defining a class that is capable of being marshaled and demarshalled automatically by the AIDL framework, even though you have to tell it a lot of information so it can do it properly. This is what's called a POJO, a plain old Java object. And basically, it represents the results of the data that was transformed from JSON into this acronym data object. And this is an example of JSON format. And I'll show you how this gets dealt with in a minute. So basically, here's what this looks like. So these are data members that are local variables that'll store the acronym data state. So we have, first, acronym data is a class that implements parcelable. That's very important. Here's the state that we want to have. String is a long form. Int is the frequency. And since is when the acronym was added to the database of acronyms. Here's a constructor that's used by the parcelable mechanism itself to take a parcel and crack it open and read that into an acronym data. So that basically creates an acronym data from a parcel. Here's the constructor that gets used in the utils directory that takes the JSON data and converts it into acronym data. So it basically takes long form, frequency, and since and turns it into an acronym data. Here's a method that returns toString. So it gives you the string version of this stuff. And then what comes down here are just mechanisms that you need for dealing with parcelables. And if you read the documentation on parcelables or parcels, it'll explain this stuff. It's rather mysterious. In my experience, you just have to basically fill in the blanks. So you have to have a method called describe contents. You have to have a method called write to parcel, which essentially will be used to write the data in the acronym data into a parcel. And then you have to create this crazy static method called creator, which is used by the Android framework in order to be able to do the appropriate methods to convert things back and forth as needed. So if you were defining something for, say, weather data, you fill this in with weather data instead of acronym data. And this is just kind of boilerplate code. This code is all very boilerplate. So that's acronym data class. And that's how you get stuff that's capable of being passed back and forth across the process boundaries in Android. Let's now go over here and we will take a look at JSON acronym data. So this is essentially the JSON acronym class is also a POJO or plain old Java object. And it has various tags we're going to use in the implementation that keep track of various fields you would see in the JSON. So we have short form, long form, frequency, and since. Those are things you will find in JSON data. Here's the fields that we've got. Here's a constructor that makes this stuff. And we have various setter and getter methods for setting and getting the fields. So this is just a very simple data type. Here's where all the real action takes place. This is the acronym JSON parser. This uses the JSON reader provided by Android, which I believe is based on JSON, just to be confusing. And here's what it does. So it basically has a method called parse JSON stream, which goes ahead and creates a JSON reader for the input stream that we've given here. And then it starts by parsing the acronym service results. Parse acronym service results. If you were to take a look at the schema for the service, you'd see it starts as an array. That's what the square bracket means. So we have to start our parse by saying begin array. And then we check to see whether or not we have an end array immediately. If we have an end array sign, that means that there were no acronyms that expanded, so we're done. Otherwise, we have to parse the acronym message. This is kind of a recursive descent parser. Here's the acronym message. It's everything from here to there. It's all that information. So we parse the acronym message. That begins by beginning an object. And then we start to read the data. We get the next piece of information, which should be SF. And if we read the SF field, we extract it from the stream. And that, of course, would have the value of BBC. Then the next thing we should find is LFS, which stands for long forms. That's this guy right here. And assuming that what happens is next an array, which it should be, of course, we go ahead and parse the acronym long form array, and then we break out. Otherwise, if we run into something else, we basically bail out because the input was malformed. I'm sure that there are better ways to do error checking for this code. I wrote this very quickly, and so I'm sure it can be done better. When we're done, we end the object and so on. Here's the parse acronym long form array. We're now parsing this part of the JSON. we begin the array, which gets rid of this character. And then we're going to go ahead and we're going to read all the contents, which should basically be LF and freak and since and something called vars, which we're not going to talk about. We're going to skip over that and ignore it. So while we're not done, we're going to parse an acronym. And to parse an acronym, we come in here and we're going to then read the next data, which is, say, LF. If we hit LF, we go ahead and set the long form to read it to the string that comes out of here. If we hit frequency, then we go ahead and read that as an integer. And if we reach a since, then we're going to go ahead and read that also as an integer. And we'll just build up our acronym that way. If we hit something else like a vars, then we're going to go ahead and just skip the vars because we don't care about vars in this case. And when we're all done, we end the object. And what this will do is this will then sort of recursively create the JSON form. It'll parse the JSON and create an acronym, a list of JSON acronyms that correspond to what was in the JSON. And then this information, this list of JSON acronyms, is then used here down here in order to be able to convert the JSON acronym stuff, which represents what was downloaded from the service, but which is not by itself capable of being passed as a parseable back and forth between the between Android. And it goes ahead and passes that stuff in a format. It creates it as an acronym data object, and then that is capable of being passed back and forth between address spaces. Now, there's obviously a lot of stuff going on here, and a lot of this is sort of mind-numbing, low-level detail. But this is kind of the way that you need to understand if you want to work with encoding formats like JSON, and you're not in a position to use a higher-level programming abstraction like Jackson or Retrofit and so on. And we intentionally do not use Jackson and Retrofit in this example because that's going to be covered in the next MOOC in the sequence, and you'll have a programming assignment that deals with Jackson and or rather with Retrofit, which basically uses Java reflection to hide a lot of the details that we're having to program here manually. So we wanted to have a programming example where you'd actually have to learn how to program and parse JSON, just because it's a good thing to know how to do, even though it's mind-numbingly complicated. By the way, there are more efficient ways to do a lot of this stuff. There really isn't necessary. It is not necessarily the case that we had to create a JSON acronym different from an acronym data. We could have merged those two things together. But what you'll find, I think, is if you understand how to do it this way, then when you do the programming assignment that deals with weather data, you'll be in a much better position to handle that, because the weather data schema is much more complicated than the acronym data schema. There's a lot more things that you're going to be getting back. And so kind of knowing how to do it this way is a good pattern to be able to get it working properly. Okay, so I think we actually covered everything. So what I'll do now is I will stop sharing and we'll then go ahead and take some questions. Let's see. Usually a JSON API should have an API version field. Would that be the first element of the JSON data? That's a good question. I don't see that as the data that is coming back from the web services. I don't know whether that's just the way that they do it, but if you try the web services, see if you find a JSON field in the information that's coming back. Interesting question. Shouldn't you check mActivity.get for null? You could if you wanted to. If it's null, then another way to handle that is just simply to have a null pointer exception handler in your code and just catch it that way. That works just as well. Oh, here's a good question. What's the purpose of having the acronym ops class, which is an interface, and having the implementation in the acronym ops impl class? So the reason I did that was because I wanted to be able to show people at a glance what the key public methods were in acronym in the acronym operations abstraction. And so by making that an interface, then it's really easy to tell at a glance what that stuff is. We could also then, of course, have different implementations that did this in different ways. For example, this particular implementation used the bound service to implement the acronym ops. If we wanted to have a different implementation, then we could have it maybe say using started services. Then it would make sense to split off the acronym ops interface from the acronym's ops implementation. And if you take a look at the programming assignment number 2 shells, you'll see an example that works that way. And I'll cover that next week when I talk about my solution for programming assignment number 2. Let's see. Is acronym ops and acronym ops impl sort of an MVC pattern? Sort of. I didn't really explicitly set it out to do it that way, though. In a real production application, would you use the same sync and async code? I would probably, honestly, if I was just writing if I was writing Android code, I would probably not use the sync version at all and just do the async version. It's much cleaner and more generalizable and doesn't have all the problems that you have with two-way calls in the Android model with application not responding issues, and doesn't require you to spawn threads and async tasks and so on. So I think I would be tempted in practice just to use the async pattern and ignore the sync pattern altogether. Although, you know, your mileage may vary, but that's what I would probably do. I simply used it like this, of course, because I wanted to show the sync and async versions, and doing it this way made it easy to compare and contrast them in an apples to apples like manner. Okay, so that is all the questions. What we're going to do now in our remaining time is we are going to go over my solution to programming assignment number 1. Let's go ahead and clean these up. All right, let's go find the right solution directory. Let's see. All right, so what we're going to do now is we're going to talk about my solution to programming assignment number 1, which you need to be aware of in order to be able to do the peer assessment properly. So a lot of this stuff we looked at in the original code walkthrough, so I'm just going to focus on the parts where we had the to-do instructions. So let's go over here to services, which is where you actually had to fill stuff in. This solution, by the way, is kind of based on an older way of thinking about things. I've since come up with cleaner and better solutions, which found their way into the skeletons for assignment number 2. But we'll stick with the assignment number 1 solution here just to have a consistent way of doing things. So download image service inherits from intent service, and we define a little tag here, which we're going to use to help with our debugging. In this particular solution, I had all my various keys in the download image server itself. I've since decided there may be better ways to do that, but that's the way I did it for now. So we have a messenger key, image path key, request code key, image URL key, and directory path name key. And then here we have constructor that sets the name of the intent service. We have our factory method. The factory method here is actually somewhat complicated because it's got to take all these parameters that are passed in and put them as either data or extras into the intent. So we make a new intent, which is going to be connected to this image service class, download image service class. We set the data field as the URL. We put the request code as an extra. We put the messenger as an extra. And we put the directory path name as an extra. Those are all things that we do. And you can see by using the factory method, we kind of keep all the details of how a service needs to be created and communicated in one place in the download image service itself, rather than strewing it all around the activity code, which really doesn't have to know anything about this stuff. This is These are secrets of how the service works, not how the activity needs to access it. Here are the various accessor methods. Again, they're cleaner ways of doing this, which are in assignment number 2. But in this case, we basically store the image path name in the data bundle. We get the results code from the arg1 field of the message. We get the request code out of a message. We get the image URL out of the message, et cetera, et cetera. Here now is the main workhorse of this thing, onHandle intent. OnHandle intent, of course, is the method that gets called back when an intent has showed up from a client. When the client calls start service, then the intent service ensures that onHandle intent gets called back. As you can see, what that does is it grabs the intent data out of the intent, and then it uses this data along. That basically gets the URI or the URL. It goes ahead and then grabs the directory path name out of the intent, and it gets the path to the image file by calling download image, passing in the URL and the directory path name, which gets us back a path to the downloaded image. We then go ahead and set the request code, extract the request code from the intent. We extract the messenger from the intent, and then we call send path, passing in the messenger, the path to image file, the URL, and the request code. And send path simply makes a reply message. We'll look at how that works in a second. And once we have a reply message, then we go and call send on the messenger, passing the message back. Now, a lot of people on the discussion forum seemed hopelessly confused by how this worked, which was a little bit mystifying to me because we've shown this code in many examples in the slides and the other videos. So I have a feeling some people aren't really spending time watching the videos or looking at the slides because all the stuff is in there. I suspect the people watching this video do not have that problem, but some people are not spending any time and then they're confused, which doesn't surprise me because it's easy to be confused if you don't spend time learning the material. So basically, that's how the messenger is used to send the message back to the activity. Here's the make reply message factory method. We make a new message, create a new data bundle, stick the image URL into the bundle, the request code into the bundle. We set the return value, and assuming that everything worked, we put the image path name into the bundle, and then we set the bundle as the data for the message, and we return the message. That's basically the make reply message code. And so as a result, you can see there's really not a whole lot going on here. The most complex part of all this stuff is just pulling the data out of the intent or putting the data into the intent in the make intent factory method, and then pulling the data out of the intent once we've got it in onHandle intent. And then after we get the results downloaded, then putting the information into a message and sending the message back. So that's really where all the complexity lies. All the scaffolding and plumbing is done for you by the implementation of the intent service framework. It's doing all the heavy lifting under the hood. That's basically what there is to it. I think this is the only file that people had to upload. So you know, it's pretty straightforward. People shouldn't be changing anything except for this one file. If people are uploading a completely unrelated solution, that really is not keeping it all in the spirit of what the programming assignment is, and it just makes peer grading more complicated. So feel free to grade that as you see fit. But that's basically what the solution looked like. And if you want to find out what all the other classes do, go ahead and watch the original walkthrough of the assignment, which walks through the various parts. Okay, so let's go ahead and take any questions that people might have as we kind of wrap up. In assignment 2, do we need to modify the code we finished a long time ago in order to make it consistent with the latest skeleton? So keep in mind what you really want to be able to do. The way things work is that when people do a peer assessment, they're supposed to download a fresh copy of the latest version that's in the repository at that point. So that way we can fix any bugs or any other things that may appear over time. So as long as your solution works with the skeletons that are in there at the end, which at this point it seems like they've stabilized, then you're fine. If you have stuff that will not work with the stuff that's in there, then you should update it. But I have a feeling that as long as the changes that were made were to files that don't actually affect the places you had to do instructions, then you don't have to update those as long as your code works with newer code, which it probably should. Let's see. I get confused between the bridge and decorator patterns. They seem so much alike. So yes and no. The main difference is that decorator allows you to transparently encapsulate new behavior onto an existing object without changing what the existing object does. So decorator is sort of a runtime pattern that allows you to add new things to be done before you do old existing things. Whereas the bridge pattern is really just about separating interface from implementation. It's not about adding new behavior onto something that already exists. It's about being able to have the interface separate from the implementation. Now, that's also, of course, what decorator's doing too. They're the same in that regard, but the way that they're used are really quite different. I would say I use bridge quite a bit, and I use decorator very sparingly. I hardly ever use decorator. About the only time I can think of using decorator was when I was implementing the application example I used in my recent webinar on Java concurrency in Java 7 and Java 8. And we used decorator for doing various kinds of image filtering operations in a clever way. In fact, that reminds me, let's see if I can bring this up here. Let's see. Switch to my, go ahead and share my screen. So if you take a look at the announcements page, I just posted a link to a 1-hour webinar I gave a couple weeks ago on Java 7 and 8 concurrency, pattern-oriented concurrency. And the video from there, the webcast of my webinar, can now be accessed at this link with this password. And it's kind of cool. It shows some other interesting things about Java 7 concurrency, things like the executor completion framework, and then it also shows some of the more interesting Java 8 concurrency mechanisms and just Java 8 mechanisms in general, things like Lambda expressions, and then it talks about streams, and then it talks about parallel streams. So it's a fun place to go to look and learn about some other topics that we aren't really covering in the Android course, but which are not unrelated to the topics that we're covering here. All right, so let's see if there's any more questions. Why use AIDL with local services? Why not use callbacks? That's a good question. AIDL with local services is kind of overkill. The only real reason I can think of using it is if you had code that you wanted to run in either a local or a non-local case, but even that is kind of goofy. So you would have to ask the Android people the answers to that questions. The skeleton code and all the assignments splits between using URIs as data and strings. Why do we not use something consistently? It could go either way. Basically, if I end up printing out the values a lot, I use strings just because they're easier to write without having to say toString all the time. If I do things internally, I use URIs. It doesn't matter. You could change all that stuff. Not a big deal. Okay. So I think we've come to the end of our session. If you have any other questions, let me know. Just a quick summary of things to keep track of. So the next programming assignment is due a week from yesterday. That's programming assignment number 2. Oh, I know what I was going to do. Programming assignment number 3. I almost forgot about that. Let's cover that real quick. That's probably a good thing to cover. Let's see. Got to remember where I put it. All right. Okay, let me share my screen here. All right, give me 1 second. There we go. So the last thing I'd like to do is talk about the next programming assignment number 3. This is what we call a mini project. We have all these in each of the MOOCs, which gives you a chance to do an implementation that's more open-ended if you desire that. And this will basically allow you to write a weather service app where you'll be defining a pair of bound services, not unlike the Acronym application, where you'll query the weather service to get the latest weather, and then you'll display it. And it's a pretty straightforward service. You can type it in, and if you follow the instructions here, it'll explain how it all works. You have a great degree of flexibility on how you design this app, although please don't use Jackson or Retrofit, because that's a third-party libraries, and that'll be confusing for people to do peer evaluation who haven't got those things configured yet. We're going to cover that in the next MOOC, so you'll get a chance to play with Retrofit in the next MOOC, at which point we'll explain all the configuration steps and so on. So don't use Retrofit for the third assignment, but here's what you need to do. You should have a synchronous and asynchronous based mechanisms using a weather service sync and weather service async, not unlike what we did with the Acronym application. And to avoid blocking the URL, the UI thread, you should use the two-way mechanism via an async task, which you can read about here. You have to handle configuration changes properly, as always. You should use the AIDL files that are provided in the very minimal skeletons that are part of this application. You're welcome to extend those AIDL interfaces as you see fit. If you want to add additional information above and beyond what we're doing here, feel free to do that. Keep in mind, though, that all the stuff related to talking to the weather service should be handled in the bound services, not the activity. So the activity should not understand or have to know anything about contacting the weather service. It should just know how to talk to the bound services using the AIDL. Another thing that you need to do to make it more interesting is implement a little caching scheme. Since weather doesn't really change on a second-by-second basis, at least not in a meaningful way, unless you're worried about, like tornado reports or something, which this interface doesn't handle anyway. You should implement a caching scheme. And I just to make this simple, I said every 10 seconds, you need to go out and get a new version of the data. Obviously, that should be a configurable parameter from 0 to whatever. And so the basic idea here is that if the weather activity is asking for the current weather, it'll talk to the weather service. Sorry, it'll talk to the bound service or bound services. And the bound services need to implement a caching model. And the way it should work is that the first time you access weather at a location, it won't be cached, of course. So it'll go ahead and download the weather data, and you'll store that. And at that point, in addition to returning that back to the weather activity, you should also cache that data for that location. And to cache it means keep a copy of it and also keep track of the time when you got it. And up to 10 seconds from that point, if there are other calls that come in from the activity to get the same location data, you don't go to the weather service again, you simply return the cached version. Now, again, this is meant to be just an example of caching. It's maybe not the best example, but it's a reasonable example, and it demonstrates the more important point about caching based on time. And so you'll have to write a little cache. I ended up using a pair of hash maps to do it. The hash map mapped location to time and location to weather data, and so I just do the logic with that. There's undoubtedly better ways to do it than I did it. The other thing to note is that you're going to have to parse the JSON data returned from making a GET request to the Open Weather Map API. And there's some information here about how to generally create POJOs for dealing with JSON data. And there's also videos on how to do this in Professor White's videos from week 3 and week 4. His videos will not be presented live. He presents them through the recorded means, but they look pretty much live because of the way he does them. They're very well done, very cleverly done, using a light board and a mirror. And so you can learn about how to do the parsing by watching what he's doing, or you can take a look at the acronym data example, which is very similar. And all the information you need to succeed here largely focus on week 3 and 4 of the MOOC. Of course, if you need to do async tasks, you'll have to go back to the earlier MOOC, but those videos are also available. The skeletons are here online. They're very, very minimal. It's just the AIDL interfaces and the weather data interface or weather data Java implementation. So you have a lot of flexibility to do whatever you want to do. This is not a trivial project. We got it done in about a day, but you know, we've been doing this stuff for a long time, and it's got some tedious parts to it. Dealing with JSON is tedious. I hate to say it, but it's probably something that everybody should know how to do because it seems to be pretty popular. And so it's worth spending a little time figuring out the tedium just because it's something that people need to know how to do. Let's see. So that's basically an overview of assignment number 3. Feel free to post questions, of course, as always. And there's a question here about caching. So the question is, well, let me rephrase. So what happens here is every time the weather activity calls a method, you know, to get current weather on the AIDL interfaces, that will talk to the bounce service, and the bounce service implements a cache, which will either go to the weather service if the cache is stale, in other words, it's more than 10 seconds old, or it'll just return the data that was returned between when the initial call was called and this point in time, if it's less than 10 seconds old. So that's what the cache means in this context. We're not going to be preemptively going out periodically and pulling the data down and storing it in the cache. That's another way to do caching, but not the way that we're doing it here. This is just a way of avoiding unnecessary network calls for situations where the data is just as good. Let's see. Is there a screencast for assignment 3? Not yet, but I'll make one. It's a pretty straightforward thing to do, and my current output is really lame, but you guys are welcome to make your display output as clever and sophisticated as you would like. You'll see, in fact, I think if you use the paid version of the Open Weather Service API, that you can actually get forecast information. That would be kind of cool. Make a little weather app that will give you the forecast for the next N days or 2 weeks or whatever, which is actually how the weather apps work in practice. But this is just an example that's really intended to give you practice with bound services and AIDL, give you practice with synchronous and asynchronous services, or AIDL programming with a binder, and also give you a chance to practice with accessing web services and using JSON to parse the data, and then using parselables to convert that into something you can go back and forth between the different parts of an Android application that uses bound services and AIDL. So you're getting a real opportunity to stretch out and try a bunch of different things in all kinds of creative ways in this third mini project example. Okay, well, looks like that's the end of today. As always, I will render the video as soon as I can, and I look forward to talking to you later.